And now I will solve a design problem from your book, problem 10-8. It is column with one-way bending. That means only one-way bending in this column. And the section is 12 by 18. That is the initially assumed or got it based on uniaxial load, uniaxial column design. Now the nominal load is given 500 kip, and concrete strength is 4000 psi, steel strength is 60,000 psi. Now again this is nominal. Nominal means we did not apply the um, or simply nominal means, so P nominal is whatever the factor load divided by the strength reduction factor. So that is called nominal load. Okay, so the load is acting at 6 inch away from the center, 6 inch away. That means the eccentricity is 6 inch. So we need to find the reinforcement in this section. How to do it? In my last video, I discussed the theory that first we need to find our gamma. Gamma is the center to center distance of the reinforcement divided by the whole dimension. So 12, why it is 12? Here to here is 12 and then 18. So gamma is 12 by 18 is 0.67. Then we need to find Kn. Kn is Pn over Az A prime C. Pn over Az A prime C. Pn given 500, Az gross area 12 times 18 divided by 4. 4. Why it is 4? Because it is 4000. I wrote here kip, so it is kip. So unit is balance. So when you are using kip here, make sure it is KSI. Okay, so something else. If in your problem they gave you PU, not PN, then what to do? Find PN using this equation. PU over strength reduction factor. For tight column, it is 0.65 or 0.7, whatever that value. So pay particular attention what is given. So here Pn is given. So we found Kn 0.58, Rn, Pn over Az. That means this portion is here. So I already know this portion 58. E by A is 6, is 18, 18, 6. So I found 0.19. Then what I'll go? I will go to your book, find the interaction diagram which has Kn here and Rn here. Then it has so many reinforcement. Then we will locate this and interpolate and find this value. That is our target. So our value is 0.67. So if I go to your book, in the appendix, find this value, rho gamma 0.67. So if I go to your book, I found a graph, say here, gamma 0.6 is graph number 2. If I go next graph number 3, gamma 0.7. So there is no graph for 0.67. So what I will do, we will use both. And you should check this also, the reinforcement arrangement. If your reinforcement is all around, then do not use it. Yes. And A prime C4, Fy60. So everything is matching for this except gamma. So if I use the first one, Kn 0.58, roughly close to 0.6. This one 0.19. So here close to 0.2. So if I use this chart, so this will be 0.58, this will be 0.19. Oh, so if I go there, if I go very, so 0.6 is here. So 1, 2, 3. I am getting like this value, rho z, or when gamma is 0.6, I am getting rho z slightly over 3%. One percent, 2%, 3%. Yes, say 0.03 1. You can read your own value 0.03032 like this. If I go to the next graph, again for same value 0.19, 0.6. So 1, 2, very difficult judgment. So when gamma is 0.7, I am getting rosy 0.026, or I can write 3.1% to 0.6%. If you use percent or value whatever, yes, roughly this. Okay, so now make a table. So when gamma is 0.6, my value is 0.031. When gamma is 0.7, my value is 0.026. So when gamma is 0.67, now you do not need to do any math to find it. Just use your engineering or mathematical judgment and try to be the safe side. Okay, so 2631, my value is 67, close to this value. That means my value will be close to this value. So 2631. So the gap is 0.005. 0.005, and my mostly there. That means 2/3, 1/3 from this side. So 1/3, 0.5, 1/3 is roughly 0.15. Yes, 0.15. So 26. So my value is coming to my rough calculation to 7 something. 7. What I will do, as I am doing a rough mathematics, I'll 8.28. I'll be in the safe side. Yes, but you can do your mathematics also, how to interpolate between two values. So I will use 1028. Then again, as you are reading the value, there might be some eyes error, human error. So that is okay. So even somebody may use 0.029. Somebody may use 0.03 even. Also right. So okay, we got our rosy. So what I will do, okay, so my AST will be 0.028, 12 times 18. So 0.028, 12 times 18, it becomes 6.05 inch square. Okay, so the design is over. Okay, now choose bar from A4 6. I can choose 6 number 9 bar, or I can choose 4 number 11 bar. It is giving me exactly 6 inches square. It is giving me 6.2 inches square. If I use other bars, yeah, you can spend so much time here to find a good number, but I will stop here. Okay, so if I use 4 number 11 or 6 number 9, 6.056 is okay. So okay, now you can start doing your detailing. So if you are using, say, this one, 1 2 3 4 5 6, right here 6 number 9, then do that. I should not waste time there. Choose your tie. As this is number 9, tie should be number 3. What should the tie spacing? 48 times lowercase d, 16 times uppercase d, or column size, which is 12 inch. 48 3/8 or 16 times 9/8. This is 12. This will be 8 to 18 inch, not good. This will be 18 inch. So 12. At the rate of 12 inch center to center. Okay, so your problem told us this will be 3 inch. So right here, this will be 3 inch, this will be 3 inch, and again this will be 12 inch, this will be 18 inch. The question is, do we need one more bar here? We have to judge what is the spacing here. If the spacing from here to here is more than less than 6 inch, then we do not need. If it is less than 6 inch, one bar can be unattended. If it is more than 6 inch, then we must need a bar. So total is 12. 3 inch, 3 inch off. So here to here is 6 inch. Inside 6 inch 3 bar. So we do not need additional tie bar here. But I see that there might be a concern about the minimum clear space. As it is 12, I should check the minimum space. The minimum clear space must be 1 inch or bar diameter. Okay, I'm not checking there. You can check, because if I check it, it takes time. Or check very quickly. That means total is 12. 12 minus 3 inch minus 3 inch. Here, done. Then 1 bar here, half here, half here. So I have 2 bar. 2 9/8 divided by 1 to 2. That is the clear spacing. So 12 minus 6 minus 2 times 9 divided by 8 divided by 2, 1.87. 1.87. So 87 is, which is greater than 1 inch or bar diameter. So it is okay. Okay, so then you can finalize this design. So hopefully you understood how to design column for one-way bending. In my next video, I will try to solve column with two-way bending. Column with two-way bending needs more work. So that will take time. Thank you.